All right, in this video, we're going to take a look at area by summations, the exhaustion method. And so we have our formulas dealing with constants, I squared, and I cubed. And we're going to utilize those here in a little bit. But first, what I'd like to do is I would like to go through and kind of talk a little bit about the formula and break it down just a little bit. So if I were to give you this situation and said, all right, the limit as n approaches infinity of the summation from I equals 1 to n of 7 over n, f of 3 plus 7 over n times I, and I said, hey, what are the boundaries? Well, this 3 is our lower boundary. And so I'll denote that by using a bracket and putting the 3 there. That means we're closed at 3. Now, this 7 over n, which appears in both of these places, designates the width. If we have 1,000,000 rectangles, we're going to take 7 and divide it by 1,000,000. That's the width. So the 7 comes from the difference between the lower boundary and the upper boundary. And since the gap between 3 and this number is 7, thus I could take 3 plus 7 and get my other boundary as 10. Our second example has 5 over n. And with this, the one thing that I need here is, let me go ahead and put the summation in here as well. I equals 1 to n. So we've got 5 over n. And we've got f of -2 plus 5 over n times I. So once again, like before, this is our lower boundary, which would be -2. And the gap between the lower boundary and the upper boundary is 5. So -2 plus 5 would put us at the right side of 3. Now, what I'd like to focus on, though, is we want to write a summation for the area bounded by the function -2x plus 8, the y-axis, x equals 1, and x is equal to 4. Now, we know it's going to be a limit process because we could use an infinite number of rectangles. N can be as big as we want it to be. So let's start with the two things that we need to find the area of a rectangle, namely the width and the length, or in this case, we'll call it the height. All right, so the width is found by subtracting the upper and lower boundaries and dividing by the number of rectangles. Since in this case, the number of rectangles is n, my width is going to be 4 minus 1 divided by n, which simplifies to 3 over n. How about the height? Well, I always like to do the upper sum method instead of the lower sum because it's a little bit simpler in terms of the formula. So this is going to be f of, and it'll be the lower boundary 1 plus the width 3 over n times I. Now, the goal is to find the area under this curve, under this graph right here, underneath the function. So to do that, I'm going to need to write this as a summation. And so let me do that right below. So we don't know how many rectangles we do want to use, but we know we're going to use a lot. So we're going to do it from as the limit as n approaches infinity. Now to this, it's going to be a sum from I equals 1 to n. I is our index, n is a constant, so n is a number. And we're going to put 3 over n here, and then we're going to do f of 1 plus, now I'm going to take that I and I'm going to have it join the 3. And it takes us to there. Now the goal is to be able to use these 4 formulas up here that we have noted. And so let's go ahead and go a little farther with this. Now we're going to simplify this. And so to do so, a good strategy. Now, it's always going to be the limit as n approaches infinity. So again, I'm gonna hold back and not include that in some of my writing here next. But we do need the sigma. So we're still I equals 1 to n of 3 over n. And let's get common denominators here. If we get common denominators, this is going to be n over n plus 3i over n. And that's going to make this n plus 3i all over n as part of the function. Now, lots of different things that we can do to simplify and to make this maybe look a little bit nicer, with the goal being to find the area. So what I do need to do at some point is I need to put n plus 3i over n into the function negative 2x plus 8. So no time like the present. Let's do that. So I equals 1 to n of 3 over n. And then here I go. It says negative 2. Where I see an x, I'm going to put n plus 3i over n plus 8. Negative 2x plus 8. I still need the summation because I haven't used any of the formulas yet. I haven't made any substitutions as of yet. So let's continue. Let's clean this up a little bit. So summation still stays. 3 over n still stays. I'm going to distribute the negative 2 through only the numerator because it's negative 2 over 1. This is negative 2n minus 6i. All right. Now, that n is over everything still. Now, the other thing I could do, because common denominators are kind of nice, and I could have simplified that maybe a little bit differently as well, but I'm going to make this 8n over n so I can combine some terms here. And I can do that. So I equals 1 to n of 3 over n, and I have a negative 2n plus an 8n all over the same denominator. Therefore, I can combine those into 6n, and then minus 6i doesn't have anything to combine with, and so I get to here. And because I've got some constants, namely the 3, the n, and this n, I'm going to take and do the following. I'm going to take a 3 over n squared out of the summation. And that's going to leave me 6n minus 6i. Now you might be looking at this and go, hey, these both have a 6. Can't we take a 6 out too, Mr. Martin? Absolutely we can. In fact, let's do it. Baby steps as we do this so you can kind of see where everything's coming. So let's take out a 6 as well. That's going to make that 18n squared. And you know what I think I'm going to do? I think what I'm going to do is this would be a fine time to split this up into 2 summations. Namely, I equals 1 to n, and all we would have left with here is n minus the other summation. All we have left for that one is an I. Okay. Good moment. Let's move on up to the top here. All right. Now, I've kind of hidden my formulas from you for a moment. But here's what we've got. We've got 18 over n squared. We have to convert this n over. And this is formula number 1. And formula number 1, back we go, on wheels. Great to be round, as those wheels are. We have an n, and n is a constant. Because n is a constant, we're going to use this formula. So n is the constant. We have to take that constant times n. So let's say we have 7. And we want to add 7 5 times. We're going to take 7 times 5 and get 35. So that's the formula we're going to use. N, which is the constant in this case, don't get confused with that, times this N right here. Plus we're going to need the I formula, which is N over N plus 1 over 2. So let's do that. So this N is going to become N times N minus the I formula, which is N times N plus 1 over 2. Now simplifying, this becomes 18 over N squared, that stays. This is N squared. And then this is going to be minus, this is N squared plus N all over 2. Now I'm going to have to distribute this negative sign eventually here. Okay. All right. Now, once you get to this point, we have to think, well, I can't combine this yet, can I? I don't have common denominators. So let's go and get common denominators. Let's make this 2 over 2. So it was N squared, now it's 2N squared over 2. Same thing, looks different. This is now 18 over N squared. And 2N squared minus N squared is N squared. But this negative sign has to run through, making it become negative N. All over 2. And they can be individual 2's if you want. Now to finish this off, we need to distribute everything through. So that's going to give us 18N squared over 2N squared minus 18N over 2N squared. And I'll simplify even farther. This becomes 9. And this becomes minus 9 over N. But the thing you have to remember is this is the limit. It's the limit as N approaches infinity. And so what we know is, that's kind of a sideways infinity. What we know is that 9 is not going to be affected. We can put any big number we want into 9. There's no N, it's just 9. But if we do it here, 9 divided by something very large is going to be heading to 0. And our result is 9. The area under the curve is 9. If we did the lower sum, we'd also get 9. But you know why else we get 9? Geometry. In fact, what I'd like to do is I'd like to graph the function. It starts at 1, goes to 4. Our function was negative 2x plus 8. If we put 1 in here, that's going to put us at 6, isn't it? If we put 4 in here, that's going to put us at 0. And you know what? It's a line. This is the region we're finding the area of. We know this has a width of 3. This has a height of 6. And yes, ladies and gentlemen, it's a triangle. 1/2 base times height results in 1/2 times 3 times 6. How about that? Through summations and using this process, we've proven the area of this particular triangle. It's 9. 9 by exhaustion, 9 by geometry. I'd do the geometry method if I were you. But my goodness, isn't it great to see how so many things in mathematics all tie together? This is the area by summations, by exhaustion, by using as many rectangles as we can to exhaust the area so that it's almost like darkened out so far. There's no little spaces in between. So thanks for watching. What I'd like you to do is continue on your practice. Take a look at the study guide problem, and I'll post that out there so you can take a look at the work with that. Tremendous amount of discipline you have to be able to do this algebraically, organizationally as well. Thanks for watching.